Let's start with the first problem, which asked for making a graph without a calculator. And you have two different graphs to do. Let's start off by looking at just the square root of x graph. If you made a table of values for this, x, f of x, what numbers could we pick for x? Well, you can't take the square root of a negative, at least not in the real numbers system, and we're graphing in the real numbers system. So x could be 0 though. The square root of 0 is 0. Square root of 1 is 1. I don't know the square root of 2 or 3. I know the square root of 4 is 2. The square root of 9 is 3. So I could use those points to graph it. 1, 1, 2, 3, 4, 2, 9, 3. That's terrible. It keeps going up, but very slowly. So it turns out it's actually half of a sideways parabola. So that's a regular function square root of x. For the domain, x can be, here let's draw a line. I like to think of it this way. The domain is what values can x take on? Well, it can't be negative. It could be 0 and anything greater than 0. So that's going to be your domain. So you could say x greater than or equal to 0. You could use interval notation and say 0 with a bracket to infinity. Or you could just, that would be the only ways you could represent it. How about the range? So the range is kind of the opposite. Think of this. And what y values will it take on? Well, it can't be any of these values. Y could be 0, 1, 2, 3, 4, and it keeps going up and up and up. Even though the graph is going up slowly, any positive number or 0 will work for the range. So, get rid of that. So your range is also y greater than or equal to 0, or we could say 0 to infinity, including the 0. So that's our domain and range. All right. So what happens when we take a function and we do something like adding a number to it? Well, that's going to be the square root of x plus 2. When you add or subtract a number inside with the x, that's going to shift your graph left or right. So, and it's going to be the opposite direction of whatever this is. So if it's a plus 2, that means we're going to take this graph and we're going to shift it 2 units to the left. So that would mean it would look like that. And all the points would move 2 units over to the left. Not the greatest picture, but you get the idea. If it was, let's say, x minus 3, x minus 3, then what that's going to do is that's going to take the square root graph, which is called a parent function, and it's going to move it 3 units to the right, so the opposite of negative. So right 3 units. So if we take our original graph again, which is there, we're going to move it 3 units to the right. So every point will move 3 units to the right. So that's how you do transformations when there's a number added or subtracted inside. On the other hand, if we, let's say we add a number outside, then what that's going to be is the square root of x plus 4. So when something's added or subtracted outside, that's going to move your graph up or down. So in this time it goes in the same direction. So a plus 4, all that's doing is making all your y values 4 bigger. So that's going to move everything up 4 units. And that one will go up 4 as well. Okay. If it was a minus 4, it would shift everything down 4 units. So adding or subtracting a number on the inside of the function moves it left or right in the opposite direction. Adding or subtracting a number after the function moves it up or down in that same direction. So plus 4 would be up 4 if it was inside. So when I look over at these, plus 1 means I'm going to be moving my graph 1 to the left, and then I'm going to shift the whole thing down 2. This one, I'm going to, with a minus 2, that means I'm going to shift it 2 to the right, and then everything will go up 3. So I'll just do a quick, without plotting all the points for that. Let's just get all these points out in here. So for the first one, the square root of x plus 1, that'll shift it 1 to the left. And then the minus 2 will move everything down 2. So if you're thinking of these points that we had plotted, that's not the greatest picture. You get the idea, though. Goes like that. That should be a little higher. All right, so that would be what the first graph looks like. So now what's the domain? Well, the x values now go from -1 to infinity. The y values go from -2 to infinity. All right, let's look at the second graph. We have a -2, so that's going to shift it 2 to the right. And then what happens when you put a negative out here? That's going to change the y values, so that's going to take this and it's going to flip it over the x-axis. So now whatever you were getting as your y values here, we're throwing a negative in front, so that's going to flip all of them. So they will all get changed. So if your graph was underneath, it would flip on top. If it's on top, it flips underneath. So the minus flips it over the x-axis. If there was a negative inside with the x, that gets more complicated, but that would flip it over the y-axis. All right, so we're going to shift 2 to the right, which I've done, and then we're going to reflect it over the x-axis. So let's see if I can flip this up, down. Okay, so it would look like that. And then finally a +3, that's going to move every point 1, 2, 3 units up. And so if you can do that using the graph, if you want to use some of these points in the table, you could say, okay, -2, that means shifting it 2 to the right. So I'm going to add 2 to the x's. So this becomes a 2, this becomes a 3, that's a 6, and that's an 11. Then I'm going to flip it over the y-axis, so then these numbers are going to become opposites. And then I'm going to add 3 to all the y numbers, and that should give you all of these points here. So for example, if you wanted to double check that you were doing this right, you could say, well, what happens if x was equal to, let's say, 2? Because I want to know when x is 2, did I get the right point here? So if I plug 2 into this equation, I'm going to get negative the square root of 2 minus 2 plus 3. That's negative square root of 0 plus 3. Square root of 0 is 0, plus 3 is 3. So that means that when x is 2, y should equal 3. 2, 3. Okay, so there's a couple ways you can do it and a couple ways to verify it. But that's how you do the transformations on these graphs. Inside, left or right, opposite direction of what the sign is. So +1 means shift it left 1. This would be shift right 2. A number afterwards is up or down. That would shift it down 2. That shifts it up 3. A negative out in front of the function is going to flip it over the x-axis. And if there happened to be a negative inside, it would flip it over the y-axis. But then the order you do things is it gets a little trickier. So that's why you didn't get one of those. All right, so hopefully that helps there. I'll just leave that there. Okay, let's solve these other three equations. All right, start with the first one. When you have a square root in an equation, you want to get the square root by itself. So I'm going to move the 6 to the other side. Then you want to square both sides to get rid of the square root. Now, whenever you do something like that, squaring both sides, you could be coming up with extra solutions. So you always have to go back and check your answers when you're done. Square root of x squared just gives me x. X minus 6 squared means x minus 6 times x minus 6. And if you FOIL, you'll get x squared minus 12x plus 36. Okay, if you have to work that out on the side, work that out on the side. Use your box or just do that. whatever you get, but you'll get x squared minus 12x plus 36. Okay, so we have a quadratic, and when you solve a quadratic, you want to set everything equal to 0. So I'm going to have to move the x on the left over to the other side. So if I subtract 1x, that'll give me a negative 13x. And now I can try and factor, and if I can't factor, I'll have to use the quadratic formula. So I know this has to be x times x to give me x squared. The other two numbers have to multiply to equal 36, but when I add them I get negative 13. Well, that would be a 9 and a 4 if they're both negative. And so therefore, I've got x equals 9 and x equals 4. Now, like I said, you got to go back and check it in the original equation. So if I plug in 9, I'm going to get the square root of 9 is 3 plus 6. And I plug a 9 in for the other x, and yeah, that's true. So the 9 works. Let's try the 4. If I plug in 4, I get square root of 4 is 2 plus 6 is 8. And on the other side, I plug in 4 for x. Uh-oh. 2 plus 6 does not equal 4. So this answer actually doesn't work. So the only answer is x equals 9. So that's why it's really important to always remember to check your answers. Because when you square both sides, which is what we did here, square both sides, you could be introducing extra solutions. And in this case, we did. Okay, that was the first one. Let's do the second one. Let's switch to green. Here, let's get rid of this graph and all of this stuff. All right, for B, we've got 5 times the square root of x plus 2 equals 12. Once again, you got to get the square root all by itself, and then you can square both sides to get rid of the square root. So first I'm going to subtract 2, and I'll get 5 root x equals 10. Then I'm going to divide by 5, and I get square root of x equals 2. Now to get rid of the square root, I'm going to square both sides, and I get x is equal to 4. Let's check if that works in the original problem. 5 times the square root of 4, which is 2, plus 2, does that equal 12? 10 plus 2 is 12. It works. So x equals 4 is my answer. Okay, let's try the last one. Now we have 2 square roots here. So what we want to do is let's get one on each side, and then I can square both sides. If I tried to just square both sides now, imagine squaring the left side. You have to multiply that whole thing in parentheses by itself. And that's going to be really messy, and you'll still have a square root as part of your answer. So let's move the 5x, square root of 5x plus 2 over to the other side. So I have the square root of 7x minus 6 equals the square root of 5x plus 2. Now I can square both sides. That'll get rid of the square root. So I have 7x minus 6 equals 5x plus 2. Let's subtract 5x from both sides. That would give me 2x minus 6 here and just a 2 over here. Then I'll add 6 to both sides. So I'll just have a 2x on the left and I'll have 8 on the right. Divide by 2, we get x equals 4. Now let's go ahead and check that. The square root of 7 times 4 is 28 minus 6. The other side, I'm going to get the square root of 5 times 4, which is 20. Just write 20. Plus 2. So here I get the square root of 22, and here I get the square root of 22. And yes, those are equal, so it works. So 4 is indeed my answer. Oops. Get rid of all this extra stuff. But like I say, you always got to check. Sometimes everything's going to work, sometimes not. And that's it.